name's Kerry Osbourne. I'm the black belt, database black belt lead at Google, and I'm going to talk about how to improve your ability to solve complex performance problems. And a little bit about me, background-wise, I am a technical guy by background. Was a developer, DBA, became a system administrator at some point for a little bit. I kind of was forced into being a business guy for a while, became a performance analyst, which is where I spent most of my career back in the business world. Have written a few books and ended up being the chief bottle washer at one of my companies. I am a serial entrepreneur, so started 3 different companies. All 3 of them had exits. One of them was sold to Accenture, one to Google. That's how I got to Google about 1.5 years ago. So sort of a wide-ranging sort of a career, I guess. And anyway, that's me. That's the the typical sort of bio that I would throw out as to what my background is. I have been working with Oracle a very long time in the database space. Although I never worked actually for Oracle, but I did work with the first commercial release way back when. So that's, sort of the normal bio. The real me is a little different, although I'm extremely analytical and, certainly somewhere on the spectrum. I also have a split brain, right brain, left brain thing going. I have a lot of creative side to me. I'm a musician, a photographer, an artist, a writer, speaker, so lots of different areas that most people would consider to be on the creative side. I am pragmatic, so I don't mind making compromises. I'm not a perfectionist. I'm okay with making some compromises in order to solve a problem. I'm optimistic. Generally speaking, I always feel like we can do better and we can solve problems that we run into, so that's just part of my nature. I love working with people, but sometimes I like working by myself as well. So I do enjoy both of those things. I've spent a lot of my career solving problems. So I've been paid to do a lot of performance tuning and internals kind of work in the database space. And, that's where I've spent a fair amount of my career. So I've also spent a lot of time thinking about how we solve problems and how we think in general. And part of that is because of the company building, thing that I went through, where we interviewed literally thousands of people, and we're trying to figure out, what characteristics would make for good problem solvers, because that's basically what we were trying to hire, was people that could solve difficult, complex problems. And so being able to predict that was not the easiest thing in the world. And so I spent a lot of time thinking about that and trying to understand that, watching literally some of the best people in the world at what they did to try to understand how they did what they did. And so that's really what the basis of this talk is about. It's really not a deeply technical talk, but more of a talk about how we think about solving problems and what we can do to improve our odds. So outline for the talk, 4 different pieces: characteristics of a good problem solver, this interview process, how do we predict and know what sort of characteristics we should be looking for, basics of how our brains work when we're in problem solving mode, some approaches, some documented and researched approaches to doing that, and just the general approach that our minds go through when we are trying to solve a complex problem. And then the last section I won't actually have time to get to, but there is a section generally in this talk where I talk about some of the cognitive biases that we have that prevent us from doing as good a job as we potentially could. So I'll probably do a recording of that as well and put it up on my blog and make that available to everybody if you guys are interested in seeing that part as well. Okay, starting with movement 1, characteristics of a good problem solver. This won't be too much of a surprise to you. Number 1 would be high IQ. We're definitely looking for people that are smart and can demonstrate that ability to think. And so that's definitely characteristic number 1. That's a requirement that we're looking for. We're also looking for hard workers, right? It's kind of odd that the combination of being really smart and being a hard worker is not all that common. Basically, the smarter we are, the less hard we probably had to work in school, the less hard we had to work, early in our careers. And so we've learned, over time that a lot of times we don't have to work as hard as, some of the people around us, which is, a benefit. But the ones that do have that kind of work ethic, and if that goes along with, this cleverness or this high IQ, sort of a characteristic, that's a magic combination. And so we definitely look for a combination of those things. Not that we have to be the smartest person in the world or the hardest working, but the combination of those two things in some measure, is an important thing that we look for. Technical background, super important, right? We have to have the technical background to be able to do the things that we want to do in the computer system space where we're trying to optimize those systems. And so that technical background is super important. We'll talk about that a little bit. And the fourth one may not resonate as much with some folks, but communication skills are super important in this space as well. If you're going to be a performance tuning person, if you're going to solve problems for large companies, even small companies that have unique problems, the ability to communicate your ideas is super important. Otherwise, you're not going to get a chance to implement the things that you think are a good idea, right? So communication, definitely a strong requirement. There's a few more that may be a little less obvious. Being relaxed is an important characteristic. Our brains behave in interesting ways when we're under stress. Oftentimes, hormones are released in our brains that shut down the higher level functions. And so the more relaxed we can be under pressure, the better job we can do at solving, these complex problems. So just a naturally relaxed personality is also a big benefit. And so that was definitely something that we learned to look for over time. Being optimistic is another one of those characteristics that, improves our chances. If we don't think we're going to be able to solve a problem, guess what? It's going to be more difficult than, if we have an optimistic attitude and believe that, we are going to be able to solve a problem. So that optimistic attitude is just something that we look for in terms of personal characteristics. And the last one that I put on the slide was being experienced and having some failures in the past is also, a good characteristic. Through some of those failures, we learn a lot of things, right? And one of the things that we learn is how to be more relaxed, because we often learn that most of us are not in life and death situations when we're at work, right? Most of us don't work on life support systems. And so therefore, when we do fail, there's usually not as high a price to pay as there are in some other professions. So, worst things that happen generally are that, a business suffers some financially, or our bosses are not happy with us. But rarely are we in a situation where, people's lives are on the line. And so, experiencing that and learning that, often can help us to be more relaxed when we are under pressure. That, this what's the worst thing that can happen, can play through our minds and make us feel a little bit better about what we're doing, and the fact that even if we don't come up with a perfect solution, it's not going to be the end of the world. So that's another thing that we would look for. Okay. I'll hit each one of these in a little more detail, but not very much. Smart, we don't have to really dig into that too much, but I did run across an article by a German general from back in the 30s that I thought was pretty interesting. And he divided his people into 4 different categories based on how clever they were, was the way he described it, and how industrious they were, how hard of a worker they were. And so, when he was dividing these people up, he basically articulated a philosophy that the very clever people who were also lazy, that tended not to be hard workers, tended to be very good leaders, because while they were smart and could make good decisions, they already had a natural bent to avoid, doing too much work themselves, which meant they started to develop skills for offloading that work or delegating that work to other people. So he felt like that category made the best leaders in general. He also wrote a whole thing up about it. And one of the things that he also pointed out was the clever, industrious people, was the people that, we're looking for when we're trying to figure out, who's going to be a good problem solver, because those are the best problem solvers. And another thing that he called out in his paper was that the group that is in the not too clever and but also industrious, that group of people were extremely dangerous in an organization. So he basically said, whoever is stupid and industrious is a menace and must be removed immediately from the organization, because they can cause no end of pain for the organization. And you guys have probably, experienced some of that sort of an environment before, I bet. Anyway, he also called out that, even those that are, not particularly industrious and not particularly smart, can be useful. And particularly he was talking about, the infantry, that those guys, as long as they were willing to do their job, could be very useful in an organization, even if they weren't particularly bright. So anyway, I found that this paper to be kind of an interesting take on the smart versus hardworking sort of categorization. Okay, moving on to technical background. Definitely important, takes years to acquire. You may have read stuff about this 10,000 hour, concept, that it takes 10,000 hours, according to some authors, to really become world-class at anything, whether that's being a musician, being a technical problem solver, or a performance tuning person. And I agree with that assessment. I don't know if 10,000 hours is the exact right number, but, it does take a very long time, multiple years, many years, a decade. It's basically what, in terms of experience, what we would typically, look for. Learning how to learn is an important part of that, right? And because if we can learn techniques for accelerating that learning, then it doesn't take as many years, is the basic crux of it. And so also, the harder you work, the more things you're exposed to, the faster you can learn, right? So it doesn't necessarily need to be 10 years or more. It could be less than that, if you are in the right environment, a consulting sort of environment, for example, where you're going from engagement to engagement and seeing a lot of different things, gives you an opportunity to learn faster. Also, the fundamentals are really important, right? Not just being a mile deep in one single thing, but having some diversity in your background is important. And so I'll digress here a little bit about how we learn. Most effective way for us to learn is to have rapid feedback. So an example of that is when we're learning to drive a car. If we turn the wheel, the car turns very quickly, right? So it's pretty easy to learn to drive a car. Learning how to drive a big ocean liner, on the other hand, is extremely difficult. When you turn the rudder or the steering wheel on one of those big boats, it takes a very long time for that boat to change direction. And so therefore, it takes a lot longer to learn how to do that. So, and it's the same with us. When we're working on an engagement, observing a production system, it takes us longer to see what happens than if we can break things intentionally. And so this learning how to build test cases that we can manipulate allows us to very rapidly make changes to a system to see how it behaves. So that's a very good way to get rapid feedback and learn in a much quicker fashion than if we're, again, just going from engagement to engagement, where we're watching particularly production systems that don't give us the opportunity to break things intentionally. I actually saw a presentation by a guy named Jonathan Lewis, who was one of the best known Oracle performance tuning guys, and he did a talk on how to become an expert. And I was pretty shocked when I listened to him do this talk, because the only thing he talked about was creating test cases. So this was a real good eye opener for me to learn that, one of the best ways to learn rapidly is to build good test cases and be able to break them and see what happens. So I would encourage you to, invest some time in that. Communication skills, I mentioned this already, but it doesn't really help you to be the smartest guy in the room if you can't articulate those ideas clearly and convince people. So I would recommend highly that you invest time and effort in improving your communication skills, because the only way that you're going to, get your ideas implemented is if you're good at communicating them. And most of us in the technical space tend to not value that skill nearly as highly as we should. We're also not going to learn as fast if we're not getting our ideas implemented, right? So anyway, I would highly recommend that you spend some time trying to improve your communication skills. That means both in the visual aspect, how you visualize things when you're trying to present them, but also your verbal communication and, your skills in convincing people, right? So there's courses you can take to help you be a better communicator in that aspect, and it's worth the effort, in my opinion. Okay, so that's it for the basic characteristics. Second, the basics of how our brains work. Our brains work in two different modes, and particularly when we're in this problem-solving space, right? And they're named, and not in my favorite way, the words that are used sometimes in the literature are intuitive, also called System 1, which is a little more generic and gives us a way that doesn't imply anything about what we think about the method. Also sometimes called automatic. So this is the mode that our brain is in when we're not really actively, effortfully thinking about something, right? And we'll talk about that a little bit. And then the other mode of thought is sometimes called analytical, or System 2 in the literature sometimes. This is the mode where we're actually applying effort and working, diligently in a focused manner in our brains, right? So, and I'll make a point, I put a little asterisk there. Our brains are naturally lazy. They want to run in the automatic mode. And sometimes we'll even do that without our knowledge. Sometimes they will switch from effortful mode into this automatic mode because that's just what our brains do. So, and I'll show you a couple of examples here. If I throw up this very simple equation, 1 + 1, and ask you what the answer is, you're not gonna apply any effort to that. You already know from your childhood that 1 + 1 is 2. So the answer is immediate. That's something that your brain does in automatic mode. Okay. However, if I throw up this equation, you're going to look at that and you're probably going to have to do a little mental gymnastics in order to come up with the answer. We can simplify this thing with a technique called substitution. So I might notice right off the bat that 19 times 35 is very close to 20 times 35, which I can pretty much do in automatic mode. That's 700. That's 20 times 35 is like 2 times 35 with a 0 on the end, right? And if I take that a step further, I could say, actually, it's exactly 35 less than 700. So I can also do that in my head pretty easy, right? So that's 665. All right, so that's a technique called substitution. That's one of those things that our brain will do, and we can do it on purpose, like I just did, but also our brain can do that to us when we're unaware of it. And so it's one of those biases that we have to be cognizant of and aware of, that our brain wants to take us into automatic mode. And so anyway, let's talk a little bit more about the intuition or automatic mode. All right, it's correct most of the time, thank goodness, because we live in that mode most of the time. And I'll give you another example. All of you have, well, most of you that drive have gotten in your car, to go to work, and you'll pull into the parking lot and not have any idea what happened between the time you backed out of your driveway and the time you got into the parking lot, right? We all do that, right? And that's because our brains are very good at running in automatic mode, and we can do some fairly complex things. Driving a car is not simple, right? We have to stop at the stoplights. We have to, make all the right turns, etc. But we can do that and not be consciously thinking about the journey or the turns or anything else, and completely be concentrating or thinking about something else. So this automatic mode, happens all the time, and it's pretty good at, dealing with day-to-day activities. Unfortunately, there are a lot of biases that can creep in when we're in that intuitive or automatic mode. And many of them we won't even know, that they're happening. So, I've already mentioned the substitution one that could be done on purpose or could be done without our knowledge, just like the driving the car thing, right? That can happen automatically. There's also one that I'm personally susceptible called "what you see is all there is." And that, is something that happens to us when I see a set of symptoms on a computer system or a database system. I have a tendency to think I've got enough information at this point. I know everything that there is to know about the problem set, which is often not true. And so I have to constantly remind myself, hey, there may be other facts that you need to be looking at before you start, trying to solve this problem. So that's one of the biases that my personality is subject to. So I have to keep that in mind. The biases are often things that we can't really turn off, right? So, and I'll give you an example of that here. If I throw this diagram up on the page and I ask you which one of these lines is longer, if you've seen this before, you might know the answer, but if you haven't, you're almost certainly going to say that bottom line is longer than the top line. If, however, I throw up some guidelines, you can see that actually those lines are exactly the same length, right? But the problem with this is you would think that once you know that, if I take those guidelines away, it no longer would look like the bottom line is longer, but that's not true. The bottom line still looks longer, even without the guidelines. So this is just a proof point that some of these mental biases that we have are not under our active mental control, right? And so there are a lot of these things, this is just a visual one, but there are a lot of these things that creep into our brains, and we can't control them, and we don't really notice them a lot of times. So anyway, this one's called the Muller-Lyer illusion. You can look that up if you're interested in reading more about it or seeing other examples of that kind of thing. All right, so let's talk about the problem characteristics for a minute of what we're trying to solve in the performance space. They're complex, right? We have almost always multiple solutions to any given problem. So if somebody comes to me and says, hey, my database is slow, there could be a million different things that could cause it to be slow or to cause the perception that it's slow. There could also be a lot of different solutions that would, or things, that we could do that would speed that system up. If somebody has a more specific issue, my IO system is slow. There are often many solutions that I could apply to make the IO system work better, right? So those solutions vary in a number of different ways. The main one that most people would think about is the benefit. If I let's focus in on the IO system is slow. I could work on the IO system to try to improve the speed of the IO system. I could put in solid state disks, for example. I could try to separate the large multi-block reads from the single block reads so that my single block reads are not delayed by having to wait in a queue behind the large multi-block reads that take longer. So there's a number of ways that I could go after that. And the benefit of each one of those potential solutions could be different. The solid state disk could speed it up 10x or 100x. Changing the queuing mechanism might, speed it up 5x, right? So there's different amounts of benefit that can be accomplished by the different solutions that are proposed. So that makes the problem space complex. Another thing that varies is the cost of implementing those things. Probably a lot more expensive to go buy a whole solid state disk system than it is to work on how the IOs are queued or something else that I can control with software. Even the cost space can vary, right? It could be a monetary cost. It could also be a time to implement, and the opportunity cost that's lost by taking longer to implement a solution, can far outweigh the monetary cost, right? So we have all these different spaces to keep in mind just in the cost area. And then there's also risk, right? So when we're talking about implementing systems and production systems, anything that you do in a production system introduces some amount of risk. And so we're often trying to minimize the risk of any change that we make while still, maximizing the benefit. So it's a trade-off between at least these three areas, and often many times, many others as well. So when we're doing work with, with people that own systems or customers, we often have to explain, hey, we've got 3 or 4 potential solutions here. What we're going to recommend is this one, and here's why we're going to recommend this one. So that last sentence, paragraph down there, tells, and this was one that we wrote a long time ago, or somebody in our organization did, and basically we're saying, hey, we are making this recommendation for two main reasons: ease of implementation and the urgency, the speed at which we can do it. So in this one, apparently this cost of time to implement was really important, and slightly leaning to urgency because it is so important to get it resolved quickly, right? So that's often something that we have to do in explaining. Here's the 5 solutions. Here's why we picked this one, right? It's not just because it's a maximum benefit. All right, so that's it for the basics of that. Movement number 3, approaches to solving the problems. So I'm going to talk about sort of the basic traditional steps that we go through when we're solving a problem in our brains, and then a couple of variations on that that are documented in studies, and also from observing, again, people that are at very high level, in our particular space, and how they pursue this. So basic problem solving steps. This is the traditional, what you would hear, from a traditional approach, right? The first step would be defining the problem. And that sounds super simple, but defining the problem actually is more important than you might think. Depending on how we define the problem, we can significantly narrow the solution space. And so we want to be very careful about how we define the problem. We don't want to define a problem. If our problem is, our user called us and said, hey, we've got this batch job that runs every night from 1 to 2, we have to deliver the end result to the next system in the pipeline by 2 o'clock. And this system is no longer getting the job done running that, in that 1 hour timeline. Okay, so how we define that problem, and then they also tell us, hey, and by the way, it seems like the IO system is the main problem. It's running slow. It's not behaving the way we're used to seeing it behave. So if we define that problem to ourselves is, the batch process is not finishing in an hour, that's a pretty good broad description of the problem. If we define it as we need to speed up the IO system is slow, that's a very narrow definition of the problem. And the problem with that is that in our secondary step, our next step is gathering data to understand what's causing the problem. And so if our definition is that the IO system is slow, whether or not we gather data in a very methodical way across a broad range of things or not, our brains, this is one of our biases, our brains are going to trick us into saying, if I think the IO system is slow, my brain is automatically going to want to discard any data that doesn't have a bearing on whether what's causing the IO system to be slow. That's just the way our brains work, is they're going to discount that data, maybe not ignore it altogether, but certainly discount it and not pay much attention to it. So defining the problem and how we define the problem is super important. Gathering data, we have to do that in a methodical fashion. And so that's the next step. Third step is postulating a reason for the problem. And we have to, in the traditional way of solving problems, it's very important that we have the mental discipline to put off this step until we've got a good definition and we've got a good set of data. Because if we don't, again, if we start postulating about the reason, as soon as we get an idea in our head of what's causing it, our brains start tricking us about, evaluating the importance of any data that we see or any symptoms that we see. So we have to be careful about that. All right. The next step is listing the possible solutions. So this is where we, use the creative part of our brains to try to come up with opportunities for fixing, the problem. Oftentimes this is where we get in a room and we're brainstorming with multiple people and we're drawing things on a whiteboard, etc. But, this is an important step and we want to give ourselves adequate time to do this, and also have an environment where, nothing is out of bounds in terms of suggestions for ideas, right? This is not the place to say, well, that's a stupid idea. This is the place to throw everything out and make a very comprehensive list of everything we can think of. Fifth step is ordering the possible solutions. This is where we start, potentially eliminating things, based on cost or risk, but certainly coming up with an ordered list of, what we think is the most benefit for the least risk and cost, and work our way towards the end where it's the most risky, and maybe it still has the most benefit, but we have to weigh those things, in conjunction with each other. Okay, and then the last step is to attempt the possible solutions in the order that we came up with. And so this is the basic approach and the basic traditional way of problem solving. Okay, now quick digression, more thoughts on gathering data. When we're gathering data, I'm going to postulate that all modern computer systems basically are made up of many components, many smaller, discrete, I'll just call them things, that we can monitor and measure. Okay, and I think most of you would agree with me on that. So if you agree with me on that, then it follows that making a computer system run faster depends on being able to identify which of those things are consuming most of the time, right? It doesn't help us to fix the thing that takes 1 or 2% of the overall time when we've got some other, thing or set of things that take up 80 or 90% of the time, right? We need to focus on the area where most of the time is being consumed and see if we can attack that, because that's where where the most opportunity is to speed up or improve the performance of the thing, right? Of the overall system. And this also implies something else that's really super critical, and that's that our system is well instrumented, right? So most database systems today are very, very well instrumented, that, we can get down to very small things, and know exactly how many times they were executed in a process, exactly how long they took historically. And we have all that information at our disposal. Many years ago, in the early days of relational databases, none of this stuff was instrumented. So we really had very little idea as to where the time was going, so there was a lot of guesswork going on. But now most things are instrumented, and it's super critical that if we're building software, that we pay attention to that and we instrument our software well. And there's always an argument about, well, it's time consuming, it slows our processing down because we're doing this instrumentation, right? We're writing data out, logging, or however we're doing it. There's a cost implied with that, but it's super critical that we have that information available. And even if it costs us a few percentage points on our performance, you cannot argue against it, in terms of supporting a large production system. All right, so I'm going to talk now about two approaches that are, in the literature and that I've seen implemented, and we'll describe them briefly and then tell you about, what I think is the best approach. But one of them we're going to call intuitive. It's kind of a helter-skelter bounce around. I have an idea and I go pursue it. The other one's some more methodical, which really tracks the traditional way of going through this very methodical approach of doing things. They both use the same steps, but we rearrange them and spend different amounts of time on them. So I'll talk about the intuitive approach first. Again, you could call this the jump around approach. The key defining characteristic of it is that we jump ahead. So I told you it's hard not to jump ahead to step 3, which is the theorizing about what's causing the problem. Keep in mind, no matter what happens when we get pulled into a situation, we have at least a little bit of information about it. Nobody says, come fix my system, and doesn't tell you what the problem is, right? They may just tell you it's slow, but there's almost always something along with that. It's slow, and I think there's an I/O problem, or it's slow, and we've noticed the I/O system is definitely slow, or it's slow, and it looks like we're pegging the CPU between 2 and 3 o'clock in the morning, right? So there's always a little bit of information that's there, which gives us, the ability to start theorizing, early a little bit. So anyway, that's the main characteristic of this approach. There's pluses and minuses, as you can imagine. We often miss important data because we're not going through a methodical data gathering step. We often come up with less creative possible solutions because we're not going through a rigorous, brainstorming session to try to come up with everything we can. But there's some positives as well, because we haven't invested a lot of time. We have the willingness, our brains are willing to quickly abandon an option. So instead of having 5 options, they're very strictly ordered, and going, through the first one all the way to the end and guaranteeing that it won't work before we go to the second one. going all the way to the end of the testing process before we go to the third one. If we go with the intuitive approach, we may check the first one, go part way down testing it, and run across some other fact that we didn't gather in the initial stage and immediately jump to option number 5 because we're pointed in that direction. And our brains are okay with that because we haven't invested, a super long time coming up with this methodical approach. All right. And the flexibility to reorder the options is basically the same as the willingness to abandon, an approach. Okay, so the second approach is the methodical approach, which is basically going dogmatically through the steps. And the key, characteristic of this one is that we have the mental discipline to postpone that theorizing step, until after we've gathered the data. And there are pluses and minuses with that. Again, problems more well-defined, more data is available, more creative solutions are possible. The negative is that, more time is invested, so it takes longer oftentimes to come up with a solution. And that is also because we're less willing to adapt the plan over time because of the amount of effort that we've invested in it. So there's also a third option, and this one is the most interesting to me and is the one, I'll jump ahead, but tell you that this is the one that I've seen be the most successful for very experienced people, right? This one combines the two approaches. It does jump to theorizing almost immediately. And the first step is jumping to theorizing. And then again, for experienced people, it's very common that they can almost immediately identify, 1 or 2 or 3 usual suspects. If somebody's been in this business for a while, they've often seen, something similar or some set of symptoms that were close. And so they can pretty quickly theorize, hey, I've seen something like this, I'm going to check this, this, and this. And they can do that very quickly and either say, yep, that's what it is, or eliminate it from contention. The key part to it is that if, the usual suspects don't pan out, that they can fall back to this very methodical approach, right? And that's a difficult thing to do because you're already in this intuitive mode where you're jumping around. There's also some negatives with this because it looks very helter-skelter, right? So if somebody's watching over your shoulder, it looks very, again, helter-skelter. So you can, in some ways, cause people who are watching you to lose a little bit of confidence in your capabilities because it does seem like you're all over the place and don't really know what you're focused on. By the way, this technique is called recognition prime decision making in the literature. You can look that up and read more about it. RPD. It's used pretty extensively in industries or professions where there's a high sense of urgency, very high stakes. So think of firefighters when they're trying to, come up with a plan to attack a fire in a large building, for example, where lives are on the line and they have to make decisions very quickly. Airline pilots also have a documented checklist that they go through in emergency situations that's based on the same sort of approach. So, all right, again, results in my opinion is that this combined approach usually delivers the best results. Again, for reasonably experienced people, and especially when the urgency is high, right? Because this is absolutely the quickest way to solve the problem, if the usual suspects pan out. Methodical approach is better than the straight intuitive approach. So for somebody that's not very experienced, that's just hopping around between things, that's generally speaking the worst approach, right? So the methodical approach is better than that, generates more confidence with customers or people that own the systems. Intuitive approach, generally speaking, is not the best for people that haven't been doing this kind of work for quite a while. But occasionally it can be the fastest. Again, if you're very experienced, for sure, but also if you're just lucky. So, sometimes people get lucky even when they don't have a great amount of experience, which actually can be a bad experience if it happens early in your career, because then I have seen people that, get used to doing this, and then it's really hard for them to go to a more methodical approach later in their career. So if you're lucky, sometimes that works out though. Okay, so that's it for the first part of this presentation. The biases is a whole nother section that's about this long, so I'm not going to undertake that here, but at some point I'll do a recording of that and put it up on my blog and make that available if you're interested. feel free to reach out to me. I'm happy to answer questions as well, offline. And here's some contact information for me. So thanks for listening. I hope you enjoy the P99 conference. A couple of those guys that I mentioned, by the way, are doing talks here. Tennell is doing a talk. I mentioned that RPD, also call that the Tennell method because that's the way he does it. And he's a very well-known, one of the best in the world at Oracle troubleshooting and performance tuning. So I'd highly recommend listening to his talk as well. Anyway, thanks for listening. Hope you got something out of it. And that's it.